I should show you just one scene from that movie, why that's the greatest teacher that ever existed in a movie. Anyway, anyone ever see Back to the School? Back to School? Nobody in here? You guys all stink. I don't. You guys don't watch good movies. It's a nice rated R. That's probably inappropriate, but all right. Did you have this on the quizzes, perchance? Did you have something like this on the quizzes where you had to distribute, and then what's I squared equal to? -1, and then you had to simplify. I'm not saying what I'm going to show you next is necessarily easier. I think it is. It's a little less work, and then it does have applications that are actually a lot nicer. So just keep in mind that that's the answer, and then let's go ahead and convert, like we have in the past, into polar. Sorry, I was trying to grab the right words there, and I got to move this. It's in my way. All right, so I always think you're a fool. What? If you don't graph. Because then you'll know what quadrant you're in and you won't make any. And then actually, in this whole set of notes I did last hour, I never did any formula. I just know A root 3, anyone? 2A. So that's 2. And then what's this angle measure? Opposite root 3, 30 or 60? 60. We did this in January. This is how I started off with the angle measures in degrees to set up the idea of why these ratios keep happening over and over and over again. So, and then guess what? We're going to do cis. We're going to do cis this whole time. 2 cis, and then that's pi over 3. Okay, so just bear with us. We're doing an extrapolation. Guess this one I'll do here. -2 root 3, yoink. 2, yoink. So -2 root 3. 2, and then, okay, here we go again. A root 3, 2A. What is the R value? 4. Come on, guys, right? You don't even have to do a conversion. You don't have to do the Pythagorean theorem if you can recognize the patterns. And then what angle measure is opposite just the A value? The 30. So it's a 30 in quadrant 2. That's 5 pi over 6. Bad 5 there. All right, and then one more extrapolation, and then our generalization is not going to be a sentence. You know me. -4 root 3, you're a fool if you don't graph this so you understand where this is located so you access the right angle measure. Down 4, A root 3, 2A, what's A? I'm sorry, what's 2A? Which is the R value? Or the Z value, whatever. I don't care about the letters. I know what I'm looking for. I'm looking for R, and I'm looking for the angle measure. What is that angle measure? What is opposite the A value? 30. What's the 30 in quadrant 3? Sorry, I had to grab the right. 7 pi over 6. Well, the first one should be easy. Hey, look at the bell work. What did we do with these two things? We multiplied. So look at if I multiply these in cis form. What's the relationship between 2, 4, and 8? What do I do to 2 and 4 to get 8? 2 times 4. And then what do you think happens with these angle measures to get that angle measure? You'd have to get some common denominator work going on here, but it definitely is add. That is actually true. This is 2 pi over 6 plus 5 pi over 6 is 7 pi over 6. So we can make that extrapolation there and assume that this happens all the time. It does. This is the only one that we're going to derive. All the others we're just going to accept. Well, there's another one that's related to this for sure. So this all looks great and fine. I really just like this last one. What happens when I take this one times this one? I take the r's and multiply them. And I take the angles and add them. And then that's my answer. Okay? You'll see in one sense this is really going to be helpful. Okay, but notice what it says. Write it in polar form and then rectangular. So we are going to have to turn it around and convert at the end. But it's good that we're in polar first, because all I do is multiply, add. This ain't no thing. Anyone? Chicken wing. Haven't had those in a while. I'm due 6 cis, oh, this is going to be easy. Isn't that 4 pi over 4, which is pi? Let's write this out. So that is one of my answers. Let's slow down. I see people looking up and down and writing. But then look at the directions that said rectangular. Okay, so I'm not writing this all out, but I will write what's cosine of pi. I actually have it right behind my head. What's cosine of pi? We have a standing coordinate plane in class with all the quadrantals noted, and then quadrant 1, fractions. So cosine of pi is -1. What's sine of pi? 0. So this equals -6 as a rectangular answer. All right? Yeah, that's all I got to say about that. I don't know if I have to. Do I have to do all of these? Can I just skip to this one? I mean, you can look at the key if you feel like you need more. I feel like I skipped this one last hour. I don't remember doing root 2 times root 2, cis, and then I need a common denominator. I did. Times 2 times, I do remember it now. Times 3 times 3, because here's the problem. That becomes 10 pi plus 9 pi over 6. That's 19 pi over 6. Look at the directions. The directions say the angle measure should be what? 0 and 2 pi. Okay, I didn't want to cheat the video here. So I got to subtract the 12 pi out of, over 6 out of that. Fumbled my words there. So if I subtract the 12 pi over 6, this just lands at 7 pi over 6. Sorry, I guess I wasn't ready. Root 2 times root 2 is 2. So it's 2 cis 7 pi over 6. So that is one of the valid answers. Then the other one is, this is what I can do. 2 cosine. Hey, what's sine of a 30? What's sine of a 30? 1/2. So what's cosine of a 30? The other one. Root 3 over 2. That's if you're still... Oh, still can't do the unit circle. Oh my gosh. It's a disaster. It's a disaster in my AB class, some of the tragedies of students that don't know the unit circle still. I don't know what happened. All right, so I don't know. I just keep writing the rectangular next to it after I simplify. Tragedy. And then you at least got to know negative, negative. That's in quadrant 3. So, okay, I feel pretty good about that answer. Just do some checking in case you do a sign error. Got it? And then, you know what? This is the one that's just kind of a leap here. Okay, so division. Look at all that stuff at the top. Yeah, forget that. Look at the bottom. To divide, instead of multiplying the r's, you divide them. And instead of adding these angles, you do what? Subtract them. It's easy. Just like the logarithm rules. Remember the log? Log base b of m times n. Product turns into sum. Log base b of m plus log base b of n. And then division turned into minus. I don't know. I just, is the way my mind works. They're not related. It's just something to think about. So this is 12. 24 divided by 2. And then cis. Oh no, I got a typo there, eh? A ghost. All right, that's 6 pi over 6. Okay, so I'm going to squeeze that in there. 6 pi over 6. 6 pi over 6 minus pi over 6 is 5 pi over 6. So subtraction. There's one of my answers. Hey, what's sine of a 30? 1/2. So this is root 3 over 2. I feel like we've had this one. This evaluation anyway. Then 12i sine of quadrant 2 is positive 1/2. And then this becomes -6 root 3 plus 6i. Okay? And then left up, that is in quadrant 2. So I feel good about that answer. Yeah, just making sure. Everyone good? Pretty easy, isn't it? Do I have to do this one, do you think? I do have to do... No, okay, good, good. Oh, no. Hey, do you remember having to do this question? This divided by this, and you had to rationalize? Remember? Remember? Wasn't that your least favorite thing you had to do, right? You had to multiply by 2 plus 2i, both top and bottom. Sorry, I lost my I there. It's all fun and games until someone loses an eye. Remember, I should have wore that shirt. Aww. I do have that. Remember that shirt? It's brown. It's all fun and games until someone loses an eye. And on my shirt, it's this student. Square root of -4 is 2. It's all fun and games until someone loses an eye, and then they get marked wrong. Anyway. So my shirt's missing the eye. That's the joke. Okay, let's move on. No. Watch. Okay? Now, you may argue that this takes a long time if you're unit circle-y challenged. I just made up something. Unit circle-y challenged. A root 2. And then what's the angle measure? So I'm going to write it and get ready. 4 root 2, sis. They all yelled 45, which is pi over 4. Yoink. And then the other one, I guess I could put this right here since I decided to put my division over here. 2. Did I do that wrong the other hour? No, I didn't think I did. -2. A root 2. And then what's that angle measure? What's that angle measure? 7 pi over 4. Okay, because that's a 45 in quadrant 4. You're a fool if you don't graph it. Notice I didn't do one time. I didn't do inverse tan. I didn't do the Pythagorean theorem because we should recognize these and make your life easier. All right, 4 over 2 is 2. Root 2's cancel. And then this is sis. Now, honestly, this is 1 minus 7, which is negative. I like doing this off to the side. That's -6 pi over 4, which is -3 pi over 2. When you reduce it, what does that become, though? What is that really? Where's -3 pi over 2 land? Pi over 2, because the directions say, again, 0 to 2 pi, right? Don't they up there? Yeah, so we got to make sure I just did that. Now, watch how easy this is. And then I got something to show you, which you're going to be mad about on the quiz is. You're going to be mad. I got to move my podium because I got to use the calculator. No, actually I don't. I already got it ready. What's the cosine of pi over 2? It's right behind my head. 0. 0 comma 1 is the point at pi over 2. 0 is the x coordinate, which is the cosine. And then sine of pi over 2 is 1. 2i times 1. I don't know what I'm doing. So 2i. What am I doing? This just equals 2i. 2i. What? Hey, look at this. Watch. Oh, no, it's not in the way. But, of course, my mouse is missing the little... See how the arrow doesn't show up? You see that? That just bothers me. Then it shows up. Then it doesn't. You see it? Do you see it, everyone? No, I'm not. So stop thinking that, stupid AI. Oh, I am in so much trouble when AI takes over. We know what you said about us. We know. All right. Oh, that's not this one. That's this one. Boom, shock. Did you see that? You actually can type this on your calculator. Get out your calculator right now. All right, so you can go ahead and I'll show you this if they allow you to have your calculator. Are you anything to the 4th power yet? No, I went out of order. Okay, I just remembered last hour. I'm like, oh, and by the way, here's the first thing you got to do, though. Go to mode, and then go to see where real is right there. I guess I can arrow down on the computer here if the mouse would show up. AI. I ran a quizzes today. Quizzes changed their format again. I didn't know what I was doing. They changed their format. It was all different. It was all discombobulated. I sent them an angry message. I did. So anyway, go there and then go ahead and type that exactly as it looks using your fraction button. Oh, don't you feel betrayed? I could have done that on the quizzes and never had to type it in. Where's the I button? It's the dot down here. So it's right, let's see if this mouse, there it is. It's right there, right there, right there, right there. Okay, all right. Everyone get that? 2i? Interesting, huh? All right, it is nice to know. What's the matter? Did you do step 1?
Yeah. A plus bi.
Give me your calculator. Let me see what you did. Stand up over here. Come here. I apologize about the wood comment before. What did you do? All right, mode. You are in A plus BI mode. What is going on here? That's wild. Who else got error? Raise your hand. It didn't work at all. That's great. I love it.
It's the older color.
It still should work. Go to. No, the mode is A plus BI mode. So over half the class it didn't work for. Oh, I'll have a seat. Sorry. Sorry about your calculator. All right. Do you guys have, oh, they have the fancy color ones here. You know, the little upgraded fancy calculators. Is that what you got back there? No? Oh, she has. Oh, yeah, you do. Yeah, it's color. Isn't that color?
It's great.
Don't you get color graph? No, the graphs are colored. Yeah. All right. So sorry about that. That's wild. No one in fourth hour said a word. All right. But anyway, by the way, A plus BI. What's A? What's A? Wrong. 0. Sorry. I can't let that go. 1. No. It's 0. Okay. What's this angle measure? What's the angle measure? Okay, so it's 2 up, so it's 2, I don't know why I'm writing it. 2 cis, because we're dividing these, pi over 2, over, and then this other one, let's just put it on the same graph, -1, negative root 3. Here we go again. A root 3, say it. 2a, and then that's cis, that's a 60 again. We've already had this, right? Didn't we? 4 pi over 3. That's the way I'd always do it back in the day. So I'm still like a triangle guy, because a lot of times a triangle does really help out. All right, common denominator, 2 divided by 2 is 1. Cis, let me hold off on this angle. Multiply by 3, multiply by 2. That's a denominator of 6, but I got to hold off. 3 minus 8. 3 minus 8 is -5 pi over 6. What is that the same thing as? Where's -5 pi over 6? 7 pi over 6, right? I hope I did that all right. I feel a little weird. 8, 3 minus 8 is -5. Okay, and then 1, what's the cosine? What's the sine of a 30? Half. So what's the cosine? Negative root 3 over 2. And then what's the sine of a 30? Half, and it's negative. 1i, and I'll put it like this, -1/2. Kind of weird where to put the I. So final answer is negative root 3 over 2 plus negative I over 2, I guess? I don't know. Or I 1/2 I. I don't care where you put it. As somebody says. Can everyone say Demoivre? Demoivre? I mean, come on. What if I took R cis and I multiplied it by itself? What if I took R cis and I multiplied it by itself? What do you do with the R's? You multiply them. So what does that mean R times R is? R what? Squared. And then you add the angle measures. But what's theta plus theta? 2 theta. So that's what Demoivre's theorem says. He figured out, okay, and if I kept doing this, if I took something by itself 3 times, then I'd take R times itself 3 times, and I'd add the angle 3 times to itself. So therefore, that's why this is Demoivre's theorem. That's a very easy extrapolation. Alrighty then. Okay, so I guess I'll do just 2 of these again as well. You can look at the key if you want. So it's 3 to the 3rd, cis 2 pi over 9 times 3, right? So 3 times 9, I already did. I knew something was wrong. I already did the canceling. All right, so 2 pi over 9. All right, then 3 cancels with 9 to be 2 pi over 3. What's 3 cubed? You guys tick me off that don't know. Where's my calculator? What's 3 to the 4th? Which I swear in AB I did that like 3 times a week, and then on the test, there was 3 to the 4th on the test, and they go, where's my calculator? You expect me to do this on the calculator? I mentioned it 74 times in my class! Anyway, it's 27. What's 3 to the 4th? 81. Oh, those ABers. Reason I can't sleep at night. All right, 2 pi over 3. All right, and then cosine. What sine of a 30? Why does he keep asking that? So this is a half because it's not a 30. It's a 60. That's how we play the game. And then sine of a 60 is root 3 over 2, and it is positive. And I got to think where I'm putting that I. I'll just put it there and then put parentheses around that. And then this is there's really no good way to write this except maybe a decimal, which I don't want to do. Fine, we'll write this one, 27 root 3 over 2, I. Just a big fat I out in front might be another way you could write it. Okay, okay. I said I wasn't doing the middle one. By the way, what's root 5 to the 6th power? What's root 5 to the 2nd power? 5. What's 5 to the 3rd? 125, because you'd have root 5 squared 3 times, right? So you'd have 3 free 5s. Hey, live long and prosper. Oh, my video, you can't see. No one even knows what this is because you don't watch anything anymore. Does anyone know who this is? That's the guy in the show in the 60s. Spock? No, anyone ever hear of Spock? I do have to retire. You guys don't know any references anymore. You don't watch anything except your little screen in your face. Nothing. Anyway, here we go. Negative 2. I had to make sure I did that right. Negative 2, comma 2. And that was always the big joke. How many people can't do the Spock live long and prosper is what he would say. And that was a Vulcan. Okay, A root 2. So it's 2 root 2. And then what's that angle measure? It's definitely a 45. So it's 3 pi over 4, right? And then this is now raised to the 4th. Oh, you know what this replaces? This replaces negative 2 plus 2i times negative 2 plus 2i times negative 2 plus 2i times negative 2. So FOIL, get that answer, and then multiply by this one, FOIL, get that answer, and then FOIL, and you get that. Blah, 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 blah. All right? Would you want to do that? No. This is why this is really valuable. Because now, what's 2 root 2 to the 4th power? What's 2 to the 4th? 16th. What's root 2 squared? 2 squared. That's 4. So root 2 to the 4th is 4. So I was kind of breaking that down. Oh. And then cis 3 pi over 4 times 4, which is simple. So that's 3 pi. So it's this answer is 64 cis, and then this ends up being 3 pi, which is, I'm not going to write this out. What's cosine of 3 pi? What's cosine of 3 pi? Negative 1, because it's the same thing as cos. Oh! I made a mistake the other hour. Wrong! What does the direction say? This answer has to be between what? 0 and 2 pi. Whoopsie daisy. I could show. I know my notes from last hour are wrong. I left 3 pi there. But anyway, cosine of pi is negative 1, so that's negative 1 times 64. And then what's sine of pi? 0. That's it. And then look at my calculator. This was the first time I got the calculator out. And then I said last hour, hey, you know what? That one from a while ago, we could also do that one on the calculator. But watch this. See? Now, in I form, you guys can't do it. Well, try it. I wonder, I don't know why your calculator's not working. I might check it after the video. But yeah, there you go. Negative 64 plus 0i. When you raise that I number to the 4th power. It's kind of fun to do. Did it work? Did yours work on that one, or did it get an error again? Did it give you negative 64 plus negative 1 point blah e? That's 0. That's just scientific notation for 0. Your calculator is not the algorithms in your calculator are not as refined as this one. I'm just being truthful. All right, and then the newer calculators probably have better algorithm. How many people got a 0 exactly on there? Because you probably have an upgraded calculator or a newer one. You got to be aware of that E number. That's just another name for 0. It's just, it is a calculator error. All right, and then the root theorem. Okay, this is, again, out of nowhere too, a little bit, and that seems a little deceiving. So I'm going to put something off to the side, write this down. Do you remember doing sine of 3 theta equals 1/2? Remember solving those? Remember? First of all, what's sine of a what is a 30? So, shoot, sine of what is 1/2? I just said it. And then what are the answers? What are the two answers for half? So it's pi over 6. What's the other one? You don't have to worry about this. So this isn't happening. You don't really have to worry about, but this action that you're going to do next happens. What happens with the amount of answers? They triple. How do I triple them? What do I add? 2 pi. So I had to add 2 pi, and this is the action I'm going to do. I just know this is what happens. So if you could just equate this to this, it's going to be a lot easier. Because this looks confusing. And then add another 2 pi, which is 12 pi. That's 25 pi over 6, right? Right. I'm getting a little self-conscious with my math. And then 1/3 them. It's the same action. Then I'll tell you what we do, and I threw one more calculator thing, and I only did 2 of these with the other hour. I like this last one. The last one's really kind of cool to do it. Okay, so understand what we're doing. What we're doing is we're cube rooting this number. So that's what we're doing. We're cube rooting. So these 3 answers, when I cube them, I should get the original. That's the point. So how do you cube root this? Well, one of the answers, all 3 of them, you cube root 8. So that, look at the formula. That's what it says. You cube root r. But then the angle measures itself says we are going to 1/3 those. All right, so you take the original and 1/3 it. And then it's add 2 pi to this and then 1/3 it. And then I'll go to this formula. That's what this says. Yeah. So I added 2 pi, then I 1/3 it. So I did it in a way, add 2 pi over 3 to all the answers. All right, but that gets a little confusing there. All right, so what's 2 pi? Isn't that 8 pi over 4? So that's 11 pi over 4. And then I 1/3 it. And then I add 2 pi again, which is 19 pi over 4. But then I 1/3 it. And then that becomes 19 pi over 12. Okay, fine. Let's write the final answer since I'm going to skip this one. That's 2 cis. Actually, the 3's cancel on this one, so that's pi over 4. 2 cis. What time is it up there? 14. Good. We're going to be good. And then 2 cis. 19 pi over 12. And then here's what this also did, but for some reason we're not getting into this. This is also helps us solve this equation. X cubed equals 1. This is what we used to do next, but then we just cut it short. Why? First of all, what works for x? What works? There's a number we should know right away. 1. And what you do is cube root both sides and get 1 and be happy. But you're wrong. How many answers are there supposed to say this number? 3. So there's 2 other solutions for this, and they're imaginary. And what math do you do? Exactly this. You would exactly do this process to get the other 2 answers. Okay, and the same thing with this one, x to the 5th. How many answers should there be for an x to the 5th? 5. One of the answers is 1. The other 4 are imaginary. And this is exactly the process you would do to solve for that. 100%. All right? 100%. And it really involves, so imagine this is like solving x to the 4th equals. This is the process I'm going to do right now is exactly what you would do. Okay, so here's the first thing. Well, I got to draw this and turn this into a cis number. 8 root 3, 2 times 8. So I have 16 cis. And then what's this angle measure? What's opposite 8 root 3? That's a 60, which is an over 3. Okay, but now what we're really doing is 4th rooting this. So again, try to keep that in mind. This is exactly like solving x to the 4th equals. This is exactly the process you would do. You would go ahead and 4th root this, 1/4 this angle measure, but there's 4 answers. What's the 4th root of 16? 2. And then cis This is 6 pi over 3 plus pi over 3, 7 pi over 3, 1/4 of that. To cis, add 6 pi over 3 to this, that's 13 pi over 3, 1/4 of that. I hope I'm doing this right, because then I have one more mind-blowing moment, maybe not mind-blowing, but 19 pi over 3, and then 1/4 of that. And then it's just 19 pi over 12, and that's it. Now, what does this mean? This means if I take this to the 4th power, then what should I get as an answer? That. And then look at the last thing that I did on my calculator, because that's a 4th root. So if I 4th it, I get that answer. So on my calculator, I did that one more time. So I'll go down to this, and that was the 19 pi over 12 answer, but it's really hard to type this in. So I needed parentheses first to enclose 2 cosine 19 pi over 12 plus 2I sine 19 pi over 12. And then you'll have to take my word for it. I raised it to the 4th power, and then look at what I got. Look at what I got. I got 8 plus 13.856 I, and then I typed, hey, is 8 root 3 13.856? Yes. So that turned into the question. So I raised one of my answers to the 4th power, and I got what I started with. Does that make sense? Okay, so that's a nice little closure to the lesson so you understand what we actually found. And I do want you to know this. This is equivalent to solving this equation right here. It's very much equivalent to that. So, yeah. All right.